This is the next slide, previous slide. Okay, there.
Okay, you heard all about the mission of the Remote Persistent Memory Think Tank. Here's a recap of that restatement. Remember that to us, persistent memory is byte addressable. So that's just something to keep in mind. We focused a lot on use cases because what we found is that you can use persistent memory in a number of different ways. Depending on the application, and the demands that it might place on the network are different, depending on which use case you're doing. So it's hard to talk about remote persistent memory requirements in general. You kind of need to categorize them by what you're trying to do, and that's why we talk about use cases. We also talked a bit about the obstacles, the gaps, the things that might need to be addressed to enable particular use cases. And we talked a little bit also about how do we know which use cases are really the most important ones. And we haven't really tried to answer that question, although there were certainly different levels of interest among the people in the room in particular use cases. And then try to construct a path forward by creating an action item for probably OFA, it turns out. So, we are asking ourselves, how big of a deal is this, right? There are a number of us that have been very interested in it, look at it as sort of revolutionary, but we all know it's going to take a long time. We can't really call out some kind of killer app right now. We're still sort of searching for it, and we're going through a process to say, what are the value, what's the return on investment for these different use cases? How much would we have to do in order to enable it, and how much do we gain, from that? So that's kind of the process we're just starting to lead into here, and these are all things that kind of contribute to that process. Pretty soon I'm going to cover some use cases. There's another thing that follows, and it's very tempting to start trying to do this right away, but we will soon, which is you've got certain primitive capabilities that you could add, functionality that you could add, to help you remotely access persistent memory, which are kind of low in the functionality hierarchy. At the other end, you've got use cases all the way at the top, and there's some kind of a cross-section or some kind of matrix that says this use case would need this feature and that feature. So that's another thing that we're probably going to lead into, as part of our understanding what's important. I did mention the OFA. We do plan to forward the use case work, forward the results of this think tank, essentially into some sessions that will take place in the OFA time slot, in the OFA group, basically. Both OFA and SNIA will be participating in that series of further discussions on use cases, and we'll jointly produce an artifact that describes them to greater depth, and then ultimately we'll probably pick a few to write more about specifically. So the use case enumeration will probably fan out in the future into several documents about particular use cases that ultimately will hopefully lead to API modifications to help enable those use cases. So when you deal with use cases, it can be a little tricky. The discipline, I think many of us have gone through that. And when was it? The 2000s use case analysis was, especially prominent then. It's still relevant, but the trick is, what's a useful level to define a use case, depending on where you're at in your process. And for this process, we want to make sure we talked about why the use case exists, what is it trying to achieve, but not so much about the details of how it would achieve it. That would be some further work, right? So as I've said, definitely why with some what and no how. So that's what this slide is describing with no pun. So of course we opened up with some general discussion. RPM is remote persistent memory. It's NUMA, right? It's going to create various paths to memory. They all look like memory access. Well, some of them, they don't have to all look like memory access actually. But in some fabrics, they, even stuff that's a little bit distant can look like memory access. So it's kind of a NUMA on steroids scenario, and you can envision kind of continuous hierarchy. There may be a lot of caching depending on the work on the use case that takes place, so as to make the hierarchy perhaps look more seamless if you're automating it. So we made some observations about that kind of potential nature, of persistent memory throughout a system. Also, it's very clear that if you look at the persistent memory technologies, one of them is essentially an NVDIMM, like what is it, the P, I think, and I get the letters mixed up. The one that has DRAM, and flash. So you're always accessing the DRAM. It has enough DRAM for the whole capacity. That one is a performance-oriented and not a cost-oriented persistent memory solution, and they exist today. So that's the one that people can try out their experiments on. However, the future persistent memory technologies that are still on their way to productization or still in research are generally denser than DRAM. So they could be a capacity play, even if you don't need their persistence, right? So I think this is something a lot of people are aware of, and so we kind of talked through that a little bit. Depending on the use case, you may be emphasizing one characteristic of persistent memory or another. Then here's a little bit of that correlation, which is revealed even more completely as we start looking through a couple of the use cases. It's a different member of the storage memory hierarchy. It's not exactly either storage or memory, especially when you get to the newer technologies that have latencies, somewhere between what you typically see from DRAM and what you typically see from a very fast SSD. So it's hard to view it as just memory or storage. So we tend to view it as another element of a hierarchy. And I mentioned caching. That'll depend on the use case. Certainly put and get type operations are relevant for some use cases that need larger data transfers. Not everybody needs cache line access. All right, so you can see why we have to go through use cases to understand this. And here's one. I have 4 of them called out in this slide deck, and then later there's another list of a dozen or so that I'm not going to go through all of. But obviously this group is very interested in the checkpoint use case and how can persistent memory help us do faster checkpoints. All right, so here's kind of a little more detail on the definition of that use case, and ultimately you end up asking yourself, okay, is this incremental? I can use remote persistent memory to accelerate my burst buffer or expand the size of the burst buffer by using either some distributed or perhaps even shared persistent memory in a system. So that's perhaps one approach. Another approach might be to do something more radically different. The point being that we definitely understand that this is a potential use case for persistent memory, and it looks like one of the ones that sparked a strong interest in this group. A second, DreamWorks is a poster child for large-scale content development, right, like movies, in which each animator, probably works on about 8 seconds of the movie for a year or two, something like that. And you see at the end of those movies, there are, the screen of animators takes like 3 minutes to go by because of that, right? But that's tricky because they kind of need to be able to see it in context. So while they're working on each individual frame, they want to go up and down to see what does the surrounding scene look like So they want to have a fast access to a repository of what everybody else is doing, so they can, can see what's going on around their work. And we think that persistent memory, both for capacity and persistence, could be an important part of that use case. All right, so that's a second use case that you can kind of picture. DreamWorks is the most interested in it specifically. They talk about it. But it's kind of they're a poster child for a certain category of work, right? Another example is machine learning, where you may have done an ingest of a large amount of data, and now you have to do a mostly read workload, and it may or may not be bulk reads. So that's another case where it could be that persistent memory, helps. Although if you're primary, it's not a great fit for devices like disk drives that are better at sequential access. The way I picture this is if I have an AI problem that I've structured as a DAG, as a graph, and I'm trying to process through it very parallel, what I'm probably doing is peeking and poking at little pieces of my neighbors all the time, right? And that's a scenario where we think that a large persistent memory might be good. And then finally, Internet of Things, where we've got huge streams of data coming in from many sensors, like video cameras and stuff like that. There was interest in this use case. It wasn't very clear what our answer would be. So this is more of an exploratory. Is there something that persistent memory could do to help this use case? There's a range then that I've talked about. What about adoption? As I said, we don't feel like we've nailed down a killer app or something like that. So it really becomes economics, right? We talked about kind of two ultimate purposes, two threads that could stem from the use case analysis. One of them is to understand what technical problems to work on in order to enable particular use cases. That's kind of the investment part. And then the other is, how valuable is this use case? It'd be nice to be able to assess it, compare it with other use cases, perhaps some that don't even use persistent memory. Is it a good deal? Right? And one of the issues we have right now is that depending on the use case, not enough of the components are available for us to put a number on that sort of return on investment. We'd like to be able to say, here's how much less this costs in terms of cost performance than this other solution. And it's still very difficult to do that with persistent memory. It's too early to do that. So we're going to have to guess, and we're going to have to use the level of interest of our constituents in order to prioritize which technical problems to solve. This is not unusual in early technology emergence, right? But still, there was a lot of consternation about, how do I know if this is really going to economically pan out? And right now, we really don't, and that's one of the reasons why it's hard to identify the killer app. There was one other highlighted here, mentioning IRA at the bottom. Suppose that you were able to, create a parallel address space across a large range of either distributed or shared persistent memory, and then create some infrastructure to allow, a kind of logically uniform but NUMA way of accessing, right, the persistent memory in that system. So that was kind of something we envisioned, so that you might have normally done that using, DRAM that could get page faults, but with persistent memory, for both capacity and persistence reasons, you may be able to do better than that. So here's where, we talked about gaps. We just talked a little bit about addressability. That's one of the gaps. We talked a lot about synchronization mechanisms. This is one of the problems that persistent memory throws at us, and the best solutions depend on the use case. We talked about availability and the problems of power fail atomics. We always get the question, can't I use transactional CPU features, right? And the issue is that those have to do with visibility across processes and consistency of the view of each process. They don't have to do with atomicity with respect to power loss, all right? So that's why there's some new problems to be solved there. How do you know if the data was good? All right, this is the problem with all of our storage technologies. Maybe we can do some things to improve on that. Then the p-commit, that's a relative of the combination of atomicity and synchronization issues. So this is the list of gaps that we put together. It's at least one form of that list. So here's where we put together a longer list of use cases, and I'm going to skip over that because I've highlighted 4 of the ones that were most interesting to the group. And here's another version of the gaps list that has a few additional things on it. So here's the wrap-up slide. Here are the people who we had involved, both from from OFA and SNIA. Of course, as you know, Paul and I were the front men for this one. But Sean and Alan are our co-chairs in the various, in the OFI WIG and the SNIA NVM programming twig. So they're also points of contact. And here are the reflectors. So expect to see us appear for further use case analysis in OFI WIG. There's my report.
Bart, go ahead.
Thank you for this presentation. I think hopefully this is very interesting. I would like to share this information with colleagues. So I'm wondering whether these slides will be published.
Yes. Simple answer.
Yeah. They'll show up in the agenda the same as everything else, right?
They're already there.
Yeah, links. Yeah. Yeah.
One thing I wanted to mention, just a sort of a process thing. It's identified as being, we're going to do this in OFI WIG to begin with. OFA is a big organization that includes, both OFI WIG and a lot of verb stuff. There's nothing about this that should be said, well, this is all about libfabric. It's not. The initial exploration that we're going to be doing is, as Doug said, is just exploring use cases. And OFI WIG seemed like the most viable active work group to do that. So that discussion about use cases for persistent memory is not going to be in the context of either verbs or libfabric because we're not at the level of talking about APIs yet. So don't be put off. Don't be thinking, gee, this is not a verbs thing, so I shouldn't go. That's not the idea at all. It's just taking advantage of a group that's currently active and currently focused on APIs to develop this idea of use cases in a public setting. So I wanted to be sure I've got that sort of out on the table.
Yeah, that's in the know-how category.
It took me a while to catch that, but I finally did. It's like my daughter. She finally noticed that K jewelry commercial, every kiss begins with K, and one day she said, I get it. Okay. Anything else on the subject of remote persistent memory? We're going to start talking about this in OFI WIG meetings, which happen on Tuesday mornings every other week, 9 a.m. Pacific. I will publish agendas on both the normal OFI WIG mailing list because it's active, as well as the OFV mailing list for that matter, as well as the remote PM mailing list that we started this week. So look for that. Thanks, Doug.